Welcome to our body filler basics video. In this video, we'll discuss different types of fillers, their applications. We'll discuss how to apply the fillers, mixing and filling. What we will not discuss is the sanding of fillers. That will be for another video. In this photo, you will see on the left side, lightweight body filler. Beside that is fiberglass filler, metal-based filler. We have a flexible filler for flexible plastic parts, and then some finishing putty. During this video, I'm going to show a few different dents. This first dent here is on a panel that has an OEM finish. The paint around the damage has been feathered back, and if you look at the center of the dent has been ground very well to ensure proper adhesion of the filler. You'll also notice that the dent is no more than 1/8 of an inch or 3 millimeters in depth, which is the maximum thickness that we want to apply body filler. This next panel here is coated with epoxy primer as per the technical data sheet for the epoxy primer. The technical data sheet for the primer and for the body filler both state that the filler can be applied directly over dried epoxy primer. This particular product needs a minimum of 48 hours dry time. And check the TDS because you may or may not need to scuff the epoxy before you apply your body filler over top of the epoxy primer. The last panel we have has an OEM finish on it, and this particular panel has been sanded. So this is OEM clear coat that has been scuffed, making sure not to burn through the clear coat at all. If we do burn through the clear coat, we must strip the paint off. So this panel has some very small dents in it, and these dents must be less than 1/32 of an inch or 0.8 millimeters in depth, and then we can apply a 2-component polyester putty directly over those dents. This is one of the rare circumstances where we do put materials over top of a painted surface. Now we're going to show how to mix body filler. So I have the lightweight body filler and the hardener ready to go here. However, as I open this can, I must check to see if the body filler has separated, and that can occur in a very short period of time, maybe even as little as half a day. So it's a good idea to have a look in the can, and if you see any separation of the solvent from the filler, make sure to stir it really well, as you can see me doing here. If there is a separation, we could wind up getting solvent and resin heavily concentrated in one area, which then changes the filler, which could be very problematic. Now I have the hardener. So this uses a cream hardener, which is a benzoyl peroxide. I have to knead the hardener before I use it to make sure that it is mixed thoroughly. It will separate inside. Now I'm taking my filler board, my mixing board, and placing it on a scale and zeroing out the scale. And then what I'm going to do is put my body filler on the filler board and measure the body filler by weight. The reason being is that body filler, unless stated otherwise on the can, is mixed at a ratio of 50:1, which is 2% hardener. So 2% hardener by weight. That's not by volume. And so yes, you can eyeball it, but mixing by weight gives you a much more accurate reading, and it'll ensure that you have minimal pinholes or other problems with your body filler. At this point, I will grab a calculator to help determine 2% of the weight, 34.2. So 34.2 grams times 2% equals 0.684 grams. And that can be rounded up to 0.7 grams. So again, the idea is I want to put in 2% of hardener by weight to the filler. So I've zeroed it back out, and now I'm going to look for 0.7 grams of our hardener to get that 2% ratio. So put a little bit on the scale. I recommend not putting the hardener directly on the filler. Put it beside it until you're ready to mix. And if you do happen to squeeze out too much, we can remove it a little bit. And there's our 0.7 as needed. If you do not need your hardener, you will notice that it will come out as a liquid, and this can cause improper catalyzation of the filler. Now I'm going to mix the body filler and hardener together using 2 spreaders. The reason I'm using 2 spreaders is to ensure proper mixing. By using 2 spreaders, I can clean one off with the other, which prevents any uncatalyzed filler from being left on one of the spreaders. As I'm mixing this together, I am pushing hard into the filler board, trying to push out or remove any air bubbles and making sure I do not add any air bubbles to the body filler mixture, which could create pinholes or pockets or cause pore adhesion. The color or streak of body filler in the filler is referred to marbleizing or marbleization. That can lead to improper catalyzation and failure of the body filler. So we are visually checking to make sure that the body filler is consistent in color before we apply it to the panel of the vehicle. I'm now ready to apply the mixed body filler to the panels. This first panel, which of course has the epoxy primer and is not sanded as per the text sheet, is ready to go as it has been cleaned. Now I'm applying the body filler by spreading it in multiple directions, pushing hard into the dent area, trying to make sure I eliminate any air pockets. Air pockets in the damage could create pore adhesion, failure, or other issues with the body filler. Once I'm finished, you'll see that I'll use the spreader to clean up the edges, which will help me when I go to sand the body filler by starting to feather edge the edge of the filler and help me feel the repair. The application on this panel is virtually the same. I'm applying it to bare metal, and what I'm doing is pushing it hard into the dent first to make sure, again, I eliminate any air pockets or potential air bubbles that may lead to failure. Then I go and apply more filler over the general repair area. The more I apply, the less pressure is applied. So I was starting with firm pressure, and now I'm going with a little bit less pressure. And you'll see I'm going to use a similar idea as the last dent in that I am going to start to work out my edges. I did notice there's not enough filler, so I am putting a little bit more material on the center and then going back and spreading it out. It is important to spend some time trying to smooth this out because it will save you effort with the sanding, but there is a limit and you do have to watch the time as, of course, the body filler is catalyzed. While the lightweight body filler is hardening, let's have a look at this short strand fiberglass filler, which is usually a green color. If you look at this, it's not mixed in the can, it's separated, so make sure to stir it. Once we're ready to mix it, we will mix it in the same manner as our body filler, and it uses the same ratio, the 2%. In here, we are using two different colors of hardener, red and blue, and the process for mixing is identical. Now, there is no difference in the actual color of the hardener. The only reason the color is added is to give us a visual aid to help us in determining if the material is mixed thoroughly. So your recommendation is to use the hardener that came with the material you bought. Sometimes it'll be red, sometimes it will be blue. There may be other colors such as white or green, depending on what the manufacturer makes. But again, the color is purely a visual aid to help you with the mixing of the product. There should be very little difference between hardeners with polyester products, but it's always recommended to use the product that came with your filler material because there may be some minor chemical differences that could cause failure down the road if you were to use the wrong hardener. And there are a few specific products out there that use a different ratio than 2%, although very few do use odd ratios. Short strand fiberglass filler has strands of fiberglass in it to add reinforcement, whereas this product you're looking at is metal based. There are no strands. It contains very finely ground aluminum powder, and that is inside a polyester resin just like all of the other fillers. Because it's within the resin, it is not going to be a contaminant on steel panels. Both are used in areas where additional strength is needed, such as over top of welds, etc. Now, when we go to mix this, there is a little difference. It uses a liquid hardener. So the liquid hardener is a different type of peroxide than the cream hardener seen with all the other filler materials that you'll see today. So this particular one is MEK peroxide, meaning methyl ethyl ketone peroxide. It has the same liquid hardener that is used in fiberglass resin. So this is still a polyester resin, just uses a slightly different type of hardener. Now we'll see with this material, it's very thick, like the short strand fiberglass filler, but it's also smoother, and it's better used in areas where you need finer finishing, additional strength, and it is also water resistant like fiberglass filler. Do note, neither of them are waterproof, and no filler should ever be applied over top of a hole or any other area such as corrosion, etc. that is an unstable substrate. So the mixing is very much the same. This particular one required 12 drops to the size of a golf ball, which is close to 2% by weight. Our body filler is now sanded, and we can see this dent has been sanded quite nicely, and there are no pinholes or defects in the filler. And if you have a look at the perimeter, it's very smooth and feathered out quite nicely. Now, if you have a look at the next panel, this is on the epoxy primer. You'll notice that the body filler has been sanded. There are sand scratches extruding into the epoxy primer, but otherwise this is a nice looking repair. Those sand scratches are acceptable, and so is the bare metal that's starting to be exposed. If you did have to recoat this with another layer of body filler, we would not want to apply it over the bare metal, as that would defeat the purpose of using the epoxy primer. The last filler material I want to show is this 2-component putty. Just like all of our other 2-component polyester products I've shown today. This one uses the cream hardener, of course, the benzoyl peroxide. Now, when we measure this one, it's also at the 2%, same as our lightweight body filler and our fiberglass filler. So I have placed this on the scale. I've weighed out 9.4 grams, and I'm going to put 9.4 into the calculator times 2, and then hit the percent button, giving me 2% being 0.188, which can then, of course, be rounded up to 0.19 or 0.2. So we will look for 0.2 on this scale. Again, place the hardener beside the filler, not on the filler. And then if you do accidentally put too much on, you can remove a little bit of the hardener. And then once you're ready to mix, same idea as before. We will always use 2 spreaders to aid in the mixing for, of course, cleaning one spreader off with the other. Although this panel was good, we will pretend that there's a pinhole. It's sometimes good to take a small drill bit to open up the pinhole, otherwise you still may wind up with a pocket underneath. Then we will take our 2-component putty and apply it over the pinhole. We'll spread a little bit on nice and smooth, and then apply it until we are satisfied, making sure that we are only putting on as much as necessary. Otherwise, you'll wind up with an uneven finish when you go to sand the putty off afterwards. This panel had the OEM clear coat prepped, ready for putty. So we are applying our 2-component putty over top of these small dents, spreading similar to before. Do note that this is a 2-component putty. It is never recommended to use an old lacquer type 1-component putty on any panels today. While that putty sets up, let's have a look at this sample panel. We can see improper prep on this panel, which is depicting what would happen if you were to apply body filler over a paint edge. We never want to apply body filler over paint edge because body filler contains styrene, a very strong solvent, which can react with that exposed paint edge, causing mapping, sand scratch, swelling, or other defects that will show up. Now, when you see these defects, they may not be obvious right away. In fact, they may look perfectly fine while in the body shop, but over time, as the undercoats and top coats cure, you may wind up seeing those scratches through later on, as we can see in the bottom left corner of this particular panel. This is what we want to avoid happening, which is why when we do repair on metal, we want at least 2 inches or more of bare metal between our paint edge and our filler material. Let's have a look at the sanded putty on these dents. The one on the left came out quite well with that small repair. And then if you look at the one on the right, we can just see outlines of the dents. There are several dents here. Normally I wouldn't fill any more than 1 or 2 dents, otherwise I'd strip the panel, but these are all very small and close together. And this does make an acceptable approved finish. Thank you.